As part of our Maker's End Inspiration series, Arduino Inspiration, one of the things we're doing is experimenting with breadboarded Adafruit NeoPixels. One of the things we needed to do during this project was chain some NeoPixels together. To do that, I wanted to make some custom 3-wire jumper cables, complete with header pins installed, to make some of that experimentation a little bit easier. So we wired those up, and as a result we'll have some jumpers that we can use when we go to connect this second NeoPixel. Today we're going to go through the steps it takes to make these little guys, but even using regular 24 gauge stranded cable, this is still a fairly stiff wire, and getting connections close to each other requires a certain amount of force. To alleviate that, we're going to use some of this crazy wire, which is still 24 gauge, but it's a much finer strand and coated with a silicon insulation, which makes it extremely flexible. So we are going to put the connectors together and create some 3-wire cables with breadboard connectors on both ends. To do that, we will need the usual suspect list of tools. We'll need wire cutters, naturally, wire strippers, pair of pliers, and you'll see why, some crimpers, some header connectors, and some pins to put into those connectors, and we'll see how all of this works. So for each one of these we're going to need 3 pins, and they come on a metal strip. You can just break them off, and these particular pins are sort of a rolled and cut steel using a stamp or a die press. If you can get these solid pins, they're actually a little bit better. I will include a photo of what these look like up close so you can see what I'm talking about, but basically they form a small U-channel at the end, whereas breadboards and people like me prefer to have just a solid round pin. So each of the pins, when it first comes out of the die, is going to have a little bit of a flare on it, and I'll put some close-up pictures of this in the video. But basically we want to take all those pins and make them the bit that grips onto the insulator, we want to make those a little bit straighter so they'll fit into the crimper when we're ready to actually crimp everything. Working with the crazy wire is pretty great if you are not trying to insert them into anything. Because it's so flexible, because the wire strands are so thin, it has a tendency to move around a lot. So what is normally a fairly easy process of making these custom jumpers and headers turns into a bit of a nightmare, especially when you are missing the use of your opposable thumb. Pro tip: if you do happen to smash your thumb with a hammer and it gets infected, do something about it right away. Otherwise you'll be as sad as I was. So the first thing we need to do, of course, is make sure that we have 3 lengths of wire, and I'm going to make a fairly short jumper. I'm going to use black for ground, which is normal, red for positive voltage, and I'm going to use yellow for the signal. So we'll have black, red, and yellow wires. And the other thing to keep in mind is that when you plug this header in, because these pins are separated in space, I don't think I'm going to be able to get that focused, the the distance to the outside pins will naturally be, if you're connecting two of these together, you need to have a little bit more wire length on the outer pins than the inner pin. We're not going to worry too much about that, and it's not a huge difference, but there definitely is a difference if you want a super neat appearance. So we're going to take just a few inches of wire, and I'm going to cut them to approximately the same length, and then I'm going to snip just a teeny bit off of the middle wire, so hopefully they'll line up a little bit better. So there's our 3 lengths of crazy wire. The middle wire is ground, which we said is the black wire, so I'm going to snip just a little teeny bit off of the black wire to make up for the slightly different lengths that will be if we were bundling the cables together. The next thing to do is to strip off the ends of the wire. I'll do one end at a time, and that way I can just speed through the second one without going through the explanations. Each of these pins has a certain cut length and strip length for the wires, because you want the insulation to be gripped on the bottom part, and the rest of the wire wants to rest on inside a little channel that's made there. So for each of these wires, we want to take off approximately 1/4 inch of insulation. It will be different depending upon which pin you're using, and the accuracy required, it is enough to be noticeable. So it does actually make a difference if you mess it up. Not a huge difference, but it can matter. So you'll want to check the specifications for the particular pins that you're using and make sure that you are following their guidelines. You'll note that I'm twisting the ends together. I'm actually doing a tighter twist than might normally be required, because this wire uses such thin strands. It's really easy to mess it up when you insert it into the pins. There are ways around this. You could tin the ends of each wire so that they are a solid unit, but then you run the risk of them not fitting into the pin. There are ways around that as well. Actually, once it's in the pin, once it's set into the pin, you could actually heat it up just a little bit and drop some solder on there. That way you're pretty much guaranteed a good connection. The issue then is that you might not be able to fit it into the holes in the jumper. So it's a bit of a fraught process, and it may not actually be worth it, but every now and then it's fun to figure out how something is done, even if you end up not going that route for your own purposes. So I'm just going to re-flatten the insulation holder part of the pin, and it'll just make it easier to deal with once we get to the crimping part. The next step is to insert the wire into the pin and crimp it using our crimping tool. There are 18 million varieties of these. This happens to be a cheap one I got off of Amazon. I would recommend not skimping on this tool like I did with this particular model, but I can't find my good one. It does make a difference. So getting the wire in is pretty much as simple as lining everything up. You want to come at it at a bit of a vertical angle, because otherwise the insulation will get caught and you won't be able to push the wire in all the way. And you do want to try to get that wire into the little wire tunnel towards the front of the pin. And I actually flattened out the pins a little bit too much. The insulation on these silicone wires is a little bit thicker than usual, but this looks like I have a pretty good connection. And then if you've done any crimping of anything, you pretty much know what's next, but you want to set this so the pointy ends are down in the crimping tool and get it lined up fairly. I'm going to have to squish down the wire grabby part. I'm not sure what the name for that is, but it won't quite fit in the crimping tool as is. It's a tweaky process, which may or may not be worth it. It's probably not, especially if you have a source of cheap cables that are pre-headered or already have pins on them. Some examples would include, especially for this because it's a pretty common number of wires, servo motors. I just pulled the wire out. Servo motors, for example, use 3-pin connectors, so a servo header would work just fine, and you wouldn't have to go through all this trouble. Also, if you're doing this with your thumb in a Band-Aid, it's pretty unpleasant because you can't actually grab onto anything with any dexterity. So I'm going to go ahead and try to crimp this again. And I'm going to come at it from this side because I might have a little better luck with the thumb. That's pretty close. So I'm going to go ahead and crimp that on. And one thing you can do at this stage also to avoid getting both sides of the header on and then suddenly having it not work, and I actually pushed it in a little bit too far, so I got some insulation in the wire contact area, which is no good. But what you can do is strip off the other end and twist that up and check it with a continuity tester, and I may actually do that now in case I mess this one up. So I grabbed my pen style multimeter. I've got a few different kinds. This one's handy for quick things, and I'm just gonna do a quick sanity check. We've got a beep. So that crimp actually went on, even though it was a little bit ugly, but that happens sometimes. So I'm going to repeat this process for the other 2 wires that I haven't done yet, and I'll include some detailed pictures, insert them into the video. Let's get started. So I've crimped on the other 2 wires, and we'll do the same sanity check with our multimeter in continuity mode, just to make sure that everything has actually worked. That one's good. That one is also good. So success on one end. Retwist these wires for the other connectors, and it's a sad day if you screw up the connector on the other end, because then you've spent a lot of time. So it's a good idea to double check your work early and often. The other thing that I'm going to show is once these pins are inserted into the block, I'm actually going to put just a little bit of heat shrink tubing around the pins. I'll put one on each side towards the connector and one in the middle, and that just helps keeps the wires together. It's totally optional. The other option is to use a larger heat shrink tubing and actually at the juncture of the wire and the connector cover up part of the connector as well, and that also provides some strain relief. Actually, I'll check to see if I have any of that, and I can show an example of that as well. The downside of using a larger heat shrink wrap, of course, is that it covers up the wires, so you can't necessarily see which section you're going in, which wires are going into which pin, and that's usually bad. So these little guys are what the pins are going to get inserted into. There is actually a direction on on most of these pins, there's a little flap that lifts up that keeps the pins from coming out. And you also need to make sure you double check which way you're putting them in. So these guys here are plus, ground, and signal. So we're going to want to go red, black, yellow. So these will go with the open side of the channel facing up. And there is actually a tool for helping get these in. I usually end up just pushing them in as far as I can without using the tool, and then switching over to, I just pull them through with pliers, which is really not a great idea, but it does work. Don't do that. Use the tool. I just happen to have misplaced mine. So I can't squeeze the header block too heavily or too hard, because it will actually break. So I just want to get enough to get a pin through, and then I'm going to pull it through from the other side. And again, I don't recommend this, but it gets the job done. Plus, with the channel ones, since it is a channel, you run the risk of crushing it and breaking it. You don't want to pull it through too far. You just want to pull it through to where the little catch mechanism is. So there's one pin through, and I will do the remaining pins. So there's one side of our completed header, and I'd like it to be stay as flexible as possible, but I'm going to put on the heat shrink now, and I'll actually shrink up one side of this so you can see the process, and then I'll do the second side of this offline, because I need to take some photos so everything makes more sense. And I can see that I've messed up some of my wire winding, so I'll have to retwist the wires. And I'm just gonna slot it up so it's about there. The exact location of the heat shrink isn't really relevant. It's not necessary at all, but it can help keep your prototype circuit a little bit cleaner. So that's what our header is going to look like. I'm going to go ahead and fire up the heat gun, little miniature heat gun. I should actually review a couple of the heat guns that we've tried. This is just a little tiny Wagner. It gets hot enough to deal with shrink wrap. It's not a super powerful heat gun. It's not designed to be, but it's perfect for this kind of stuff. Don't put your hand on the outside of the heat gun. And also, remember to put on all of the heat shrink that you need at this stage rather than waiting, because once the other header is on, you can no longer get your heat shrink tubing on. So I'm going to go ahead and put the other two pieces on now. That way, when I'm all done, I'll actually have my heat shrink on. I've made some of these cables where I get both ends on, and I realize that I left off one piece of heat shrink. Again, the heat shrink is really just a neatness factor. It doesn't provide any useful value other than keeping the wires somewhat closer together, and they take up less space than like a zip tie or something, which also works, or twist ties, or you can just hot glue some sections together, whatever works. So now we're ready to put the pins on the other side. I'm gonna blast through that offline, and I'll come back when those 3 pins and the other header are attached. So I've put both headers on, and I'm about to heat shrink it up just so it's a slightly more unified package, and then we'll test it out to make sure that it actually works. And this circuit obviously doesn't show it being used for anything useful, because I'm just connecting two things together that don't need to be connected. And again, whether or not this is useful depends on your project. For 3 wires, it likely is not a very strong value add. But when you are dealing with longer runs of cables, or you need to be able to check functionality quickly, it can be a big win. So we're just going to double check to make sure that this actually works. And we're going to take our new jumper cable, which is significantly more flexible than the old one. We'll plug it in here, and we'll just drop it over here. And we'll plug this in, and it should work. So we made a custom cable. This one happens to be lined straight through. So if both sides are facing the same way, red is on the top in both, yellow is on the bottom in both. One need is often to swap cables around, swap individual wires around. So you might reverse the red and yellow cables depending upon what you were doing or the distance you were going. The longer distance you have, the less need there is to swap a cable around, especially when it's just jumpers. If it's a lined connector like a D connector and you need to swap things, then you just have to swap them. But for breadboard jumpers, it doesn't matter. So there's our custom-made 3-pin jumper cable. Whether or not it's worth it, probably not, but it does give you an opportunity to have a slightly cleaner breadboard. So instead of having multiple jumpers like these looping between components, you can just have a ready-made cable. And since we prototype with these NeoPixel LEDs fairly often, something like this actually comes in handy. So we've made several of them, and we'll continue to make them as necessary. Thank you very much. I hope this has been instructive. There'll be a blog post with the contents of this video and more pictures than were shown on the video.